We will see the Laplace transformation of derivatives. If Laplace transform of t is given as fs, then how do we write derivative? F dash t. So if this is continuous, you know what is limit continuity and derivability. So if f dash t is continuous and Laplace of ft is fs, then Laplace transform of f dash t, that is dft by dt, is given by s fs minus function of s at s equal to 0, the initial value. In general, if this be Laplace transform, we have to find Laplace transform of f to the power nt, the nth derivative. It is given by s to the power n fs minus s to the power n minus 1 f0, s to the power n minus 2 f dash 0 up to f n minus 1 n minus 1th derivative at s equal to 0. So this is the general formula. This is how we treat derivatives. If we have a derivative, we take the transformation like this. So this is the Laplace transform of derivatives. Now let's see Laplace transform of integral. I am not going into proof because that is too mathematical, too theoretical for engineering. In engineering, we do not require this type of proofs. So what I was saying, if we have to take 0 to t fu du, this is an integral. So what will be the Laplace transform of this? It will be s of fs, where Laplace transform of ft is fs. So for integral we have this, and for derivative I just told you. Let's say we have function of t. We know that Laplace transform of ft is fs. We have the standard notation, Laplace transform of ft is fs. What we want to know is multiplication by t to the power n. What if we have to find the Laplace transform of t to the power n into ft? We know Laplace transform of ft is fs. What if we get Laplace transform of t to the power n ft? This is minus 1 to the power n, then nth derivative of fs. This is how we evaluate or how we take the Laplace transform of a function multiplied by t to the power n. We have another function which is very important, another method. What if we have to find 1 by t of ft? We know Laplace transform of ft is fs. What if we have to find Laplace transform of 1 by t into ft? So this is s to infinity fs ds, multiplication by t to the power n and division by t. So we have seen so many transformation methods. Now we will start examples to understand these transformation methods. Let's say we have to find Laplace transform of t sine 3t. Very simple. We know that Laplace transform of sine 3t is 3 by s square plus 3 square, that is 9, and Laplace transform of t into sine 3t, it will be minus 1 to the power n is 1, so this will be minus nth derivative, this is 1, so first derivative d by ds of fs, that is minus d by ds of this thing, 3 by s square plus 9. So this is minus 3 minus 2s by s square plus 9 whole square. So this will be 6s by s square plus 9 whole square. So this makes our effort very easy. Otherwise we had to take 0 to infinity e to the power minus st into t sine 3t. Evaluation was very difficult. By this, the evaluation has become very easy. Similarly, let's complicate this matter a bit more. What if we had to find the function of t into e to the power minus t into sine 2t? Now this is a big function. Taking Laplace transform from the basic method, that is 0 to infinity e to the power minus st into t into e to the power minus t into sine t 2t dt, this is a bit difficult process. What is the easy way? We know that Laplace transform of sine 2t is 2 by s square plus 4. Then Laplace transform of e to the power minus t sine 2t, a, e to the power at, s minus a. So this is 2 by, this is minus 1, so s plus 1 square plus 4, which is equal to 2 by s square plus 2s plus 5. And now when we multiply it by L t e to the power minus t sine 2t, what is it? It is d by ds of this 2 by s square plus 2s plus 5. What it will be? This will be twice 2s plus 2 by s square plus 2s plus 5 square. So these transformation methods make Laplace transformation so easy. Otherwise, if we had to start with this integral, that would have been very difficult. So we have seen some examples when the function is multiplied by t to the power n. Let's see one example on 1 by t of ft. Let's say we have to find sine 2t by t. This is not very difficult because we have seen what if we have to take function f a t. You remember Laplace of f a t. This is equal to 1 by s and then function of s by a. So this is not a very difficult question. You can find from directly from here. You can multiply by 2 and then this. So this becomes very easy. Let's see some difficult question. So let's see, our function is 1 minus e to the power t by t. What is the Laplace transform of 1 minus e to the power t? It is 1 by s minus 1 by at, s minus a. So this will be s minus 1. Okay. Now Laplace transform of this function into 1 by t. So that will be, as we had seen, s to infinity 1 by s minus 1 by s minus 1 ds. What is this? Log of s minus log of s minus 1, 0 to infinity. This is log of s by s minus 1, 0 to infinity. We can write it like log of 1 by 1 minus 1 by s, the limit is 0 to infinity. So this will be log of 1, infinity, this is 1 by 1, that is 0, minus log of, sorry, not 0, log of s. So log of s simply. So this will be s by s minus 1, minus, just it reverses. So this will be log of s minus 1 by s. So we saw that when we have the function multiplied by tn or by 1 by t, we have a very beautiful method to solve such problems. And we have seen the transforms of derivatives and integrals. We will use it when we will see the application of Laplace transform. We will see how differential equations are solved. There we will utilize those two properties, Laplace transform of a derivative and Laplace transform of an integral. So this is about Laplace transform. These are the methods for transformation. You should go and solve problems from your book. Next we will start understanding inverse Laplace transforms. So before that, complete your transformation part, so that we are able to understand inverse Laplace transform, and then we will see the applications of Laplace transformations. Thank you.